Welcome to part 5 of our TensorFlow Object Detection API tutorial series. In this part and in the future, we are going to cover how we can track and detect our own custom object detection with this API. So I'm doing this by using the pre-built model to add custom detection object to it. That's a decent jump from my findings, and it's quite hard to locate any full step-by-step tutorials. So hopefully I can help you with that. Once you finish this tutorial, you will have the ability to train for any custom object you can think of. So that's an awesome skill to have in my opinion. Alright, so this is my overview of the steps needed to do in this whole tutorial to detect custom objects. So at first, we need to collect at least 500 images that contain your object. It can be even 100 if the object is not difficult and don't have many details. So the bare minimum would be about 100, ideally more like 1000 or more, but the more images you will have, the more tedious step second will be. So in the second step, you should annotate the images. So I'm personally using label IMG. This process is basically drawing boxes around your objects in an image. The label program automatically will create an XML file that describes objects in the picture within coordinates. So next, when we are done with annotating the images, we need to split this data with train and test samples. So training data should be around from 80 to 90%, and testing data should be from 10 to 20%. Next, we should generate TensorFlow records from these splits and set up configuration file for the model of our choice. You'll see what I'm doing. So I'll show everything step by step. Well, at least I'll try. And after making all the configurations, we'll be able to train our model. And after that, we need simply to export inference graph of our trained model, and at the last step we should use this pre-trained model for detecting our custom objects, the same we did in pre-trained model in previous tutorials. As I told you before, TensorFlow needs hundreds of images of an object to train a good detection classifier. Best would be at least 1000 pictures for one object, but to train a robust classifier, the training images should have random objects in the images along with the desired objects, and should have a variety of backgrounds and lighting conditions. There should be some images where the desired object is partially obscured, overlapped with something else, or any halfway in the picture. In my classifier, I'll use 4 different objects I want to detect. So it will be terrorist, terrorist heads, counter-terrorist, and counter-terrorist head. For this, I used to play Counter-Strike Go with harmless bots to gather hundreds of these images. I was playing on few different game apps, and also I was grabbing some pictures from Google to make them different from my game. So I'll begin with labeling images, and here is my images. I have, well, this is not a lot of these photos, but it's around 80 photos. Here should be written, and yeah, it's 83 photos and our image labeling program. And here comes the best part. With all pictures gathered, it's time to label the desired object in every prediction. So I'll post the link to this program in my comments under the video, and there will be all the installation guides and whatever you'll need. So when running this, you should get a guide window. So let's open it, and then we open our working directory. Okay, and now we just need to start doing our job. So I was doing it like this. I'm grabbing a create rectangle box and I press. It's terrorist head. Okay, one head, another head, and now I draw a box around whole terrorist, and here also terrorist, and press the save button. And then we go to another image and so on. Counter-terrorist head. So C head. Oh, sorry, I made a mistake. C head. Here is our T head. And here is our counter-terrorist. And I save it again. So I'll do it about, I don't know, hundreds of times. So I'll stop my video to do all the labeling stuff here. So it might take for me half a day, but yeah, I will do this. By the way, keep in mind, this will take a while. So here I'm back and I finished labeling my images. So what I have is I have about 130 images in my test directory and around 500 images in my training directory. So I have around 600 images or more, and I separated them, as I told you before, to training and testing directories here and here, and it is in CC Go images folder. There is another training folder and few other Python files, so I'll explain everything in a moment, but I want to begin with an images labeling. Once you have labeled your images, we separated them into training and testing groups. So to do this, just copy 20% of your images and XML files generated with a program to the testing directory, and what's left, transfer them to training directory and leave them as it is. So next, it's time to generate TensorFlow records that serve as input data to the TensorFlow training model. This tutorial uses the XML to CSV, the Python file, and generate TensorFlow records script. Here, this, and I took these files from Edge Electronics repository, GitHub. So it's also object detection tutorial that was with card detection. That was amazing tutorial, and with some slight modification to work with our directory structure, I modified these two files. So first, the image XML data will be used to create a CSV file containing all the data from the train and test images. So I can open this Python file, and as you can see, I changed the file structure here, that all my images is in this folder, and we need train and test folders, which are already in this folder. So it's quite simple. Now I need to start using this, so I'll create a small script file which we'll use to create our CSV files. So I'll create a new text document, call it the same as Python file, to csv.bat. I'll use batch format, and so what I wanted to do is to open my Python file, and we use pause. Okay, and let's try to run it. And here should appear two files. Yeah, they appeared, and sorry, this created train label CSV and test label CSV files in my folder. So as I mentioned before, if you're using different file structure, please change this Python file accordingly to your file structure, and at the same you can use this CSV batch file. What we'll need to do is next to open a generic TensorFlow Python file with text editor, or doesn't matter, I'll open it with my Python editor. You don't need this anymore. And as you can see already, the prepared this Python file for myself here, and as you saw in labeling while I was showing them example how to label images, I wrote a C, CH, T and TH. So I need to change this to bigger letters. This is a short. Okay, and this file also is took from Edge Electronics GitHub repository. So if you are doing your own object detection and not using my tutorial, you can replace the label map with your own label maps, where each object will be assigned with an ID number, and the same number assignment will be used when configuring the label map pb.txt file. So I'll show this in a moment. So I can close this. I think now it's only these lines we need to change, so we don't need this anymore. I will close this, and now I think we can try to generate our TF records, and also maybe we'll try to create a bash script. I'll call it the same, but now it will be not that simple as before. So what we'll do is we are opening generate TensorFlow Py file. Okay, and we need a few lines from here. We'll need this image directory, yeah, this, and output path, this. We don't need this anymore, so we need this, and now we simply write what it requires us to write. And this will be train labels dot csv. Next is another image directory. What is my equal to the same, and here is train, and next is output directory path, so it will be also ccgo images, and here goes our train record. I think I wrote everything correct here. Train labels, train records. Okay, we copy this line, and here we change train to test, and here also goes test record. I save it, and I think it should be fine. I will try to run it, and here should appear two files, test and train records. Okay, let's run it and let's see. Something happened. Yeah, so they were created, and these files will be used to train the new object detection classifier. Okay, so the last thing to do before training is to create a label map and edit the training configuration file. The label map tells the trainer that each object is by defining a mapping of class names to class ID numbers. So use a text editor to create a new file and save it as label map pb.txt in the training folder, and make sure the file type is pb.txt and not txt. And in the text editor, write the labels in the same format. So here is my training folder, ccgo train, and here I have this. I will open it in pb.txt in Notepad++, and I change this to bigger letters. Okay, and what else I need? I don't know. So the label map ID number should be the same as what is defined in the generate TensorFlow records py file, and yeah, they are the same now. I'll check them again. Yeah, it should be fine. So next, I think you're wondering what is faster recurrent neural network inception v2 coco config file. So this is the file, and I'll show you where to get it. I go to my C disk for my TensorFlow, and I go to research, object detection. Now I go to samples, configs, and here are all the pre-trained models configs files. So I'm using the faster recurrent neural network inception v2 coco model for training. So, and I will use this config file. So for this v2 coco, here it is, and yeah, I just copied it here, and I already changed these few lines, so I'll open it to change what you need to change. So I'm using number of classes is 4. This line should be changed. Next goes this line, fine-tune checkpoint. So this is the what model we are using. So in previous tutorial we used the same model for the pre-trained object detection. So we use the same model for training our heads detecting. And next, what we are changing is the directories. So input path is quite simple. Where's our train record file? So and test record. So we change this line, and then label map path also need to be changed. So it is in our training directory, and it's quite simple. Yeah. Okay. So save the file after the changes have been made, and that's it. The training files are prepared and configured for training, and one small step left before actual training. So I'll close all my files and I go here, and now I need to go to my TensorFlow object detection directory. So I again go to C, TensorFlow, research, object detection, and I need to copy few files. But yeah, I need to copy these two folders, and actually I'll use training py file, but in older versions of TensorFlow we were using py, but in this version you can't find it. So if you don't have this in your directory, you can use mine. I'll upload this to my GitHub repository, or you can go to legacy folder of your TensorFlow object detection file, and here is our train file. So okay, let's move back, and what I'll do next is, yeah, I copy these files to my object detection folder. I already have copied them, and we need this. And the last step you need to do is run the actual training. So for you, I can create a train bat file again, and we can call it training batch. Yeah, we create it, and again we use notepad to this, and what we'll write is python train.py and log to stdir train directory is, we'll call it ccgo training directory. Okay, and pipeline configuration path equals to ccgo training, and not to make any mistakes, we'll copy this and paste it. Okay, I hope it's everything fine written. I'll copy this. Oh no, not copy. Before that, I need to copy these files to my object detection repository. So as I told already, I have already them copied, and sorry. Yeah, I need to run actual training. So I open my command prompt, run as administrator, and cd this, and then I copy my line, pretend line, and simply pasting it here. I don't know why, but it was not working with my batch file, so I'm opening command prompt with administrator rights. I don't know why, but for some reason it doesn't work without administrator rights. And yeah, it's easier just always run it as administrator. So yeah, it will begin to train, and that's it. We wait for actual training to finish. So that's all for this video. I hope that this was useful tutorial for you, and in next tutorial we'll show you how to export our trained model, and we'll check how it works. So if you have any questions, be sure to leave them in comment section below this video. If you liked my video, yeah, you know what to do. Smash up the likes button and subscribe my channel. Then you'll get more of my videos. Text version of this tutorial and links are left in video subscription. Thank you all for watching. Good luck and see you in the next video.